In this question, we are going to find inverse of matrix A, and for that we need two things: determinant of A and adjoint of A. So first of all, let's find out determinant of A by simply cross multiplying. 3 2s are 6 minus 4 minus 2s are minus 8. So here we'll get 6 plus 8, or we can say 14, which is not equal to 0. Therefore, we can say A is non-singular matrix and hence it is invertible. So let's get our second required quantity, which is adjoint of A. Here we have 2 cross 2 matrix and its adjoint can be formed by interchanging principal diagonal elements. That means your 2 will move to A22 and your 3 will move to A11. And for the rest of the elements, we have to change their signs. So minus 2 will become 2, 4 will become minus 4. So here we get our adjoint of A, and we are ready to find out inverse of matrix, which is nothing but 1 upon determinant of A into adjoint of A. So let's get your 1 upon determinant of A, which is 14, and your adjoint of A. So here we get our A inverse. Ta-da! Let's try to solve next question. Here we have to find inverse of matrix A, and for that we need determinant of A and adjoint of A. So first of all, let's try to get your determinant of A by simply cross multiplying. This 2 multiplied with minus 1 will give us minus 2, minus 3 multiplied with 5 will give us minus 15. So here we'll get 13, which is not equal to 0. Therefore, we can say A is non-singular matrix and hence invertible. So let's get your required second quantity, which is adjoint of A. Your matrix A is 2 cross 2. So its adjoint can be easily found by interchanging principal diagonal elements. So this minus 1 will move to A22 and this 2 will move to A11. And we have to change the sign of rest of the elements. So here we'll get minus 5 and plus 3. So we get our adjoint as well as we are ready to find out A inverse, which is nothing but 1 upon determinant of A into adjoint of A. So let's get 1 upon determinant of A, which is 13, and adjoint of A. So here we get our inverse matrix. Ta-da! In this question, we have to find adjoint of matrix A, which is order of 2 cross 2. And to find out adjoint of 2 cross 2 matrix, we have one easy method. First of all, we have to interchange principal diagonal elements. That means your 1 will move to A22 and this minus 4 will move to A11. And the next step is change the sign of rest of the elements. So this 2 will become minus 2 and this 3 will become minus 3. So we get our required adjoint of A, and this will be helpful to find out inverse of matrix. Ta-da! In this question, we have to find adjoint of matrix A, which is order of 3 cross 3. Now, adjoint of A can be defined as transpose of matrix which is made up of cofactors of respective elements. Now, our matrix is 3 cross 3. So, their cofactors must be of order of 2 cross 2. So, let's make 9 2 cross 2 determinants. And don't forget the transpose. Now, to get the sign of cofactor, you have to use symbolic determinant format for 2 cross 2. So, for first row, the signs are plus, minus, plus. For second row, it is minus, plus, minus. And for third row, it is plus, minus, plus. Now we just have to find out minor of respective elements. Now first of all, we have to find out minor of 1 1, which is in first row and first column, and for that you have to ignore first row and first column. So we get the elements of minor of A11. Now your next element is minor of A12. So we have to ignore first row and second column. So your column will be 2 minus 2 and 5 1. And the third minor is in third column. So ignore first row and third column and you will get minor of A13. So we successfully get the minor of first row. Now let's try to get minor of element of second row. Your first element is in first column. So ignore first column and second row. So we will get minus 1 and 2 and 0 and 1. Now your second element is in second column. So ignore second row and second column. So you will get 1, 2, minus 2 and 1. The last minor of second row is in third column. So ignore second row and third column and you will get 1 minus 1 and minus 2 0. Now let's get minor of last element. So this time you have to ignore third row. The first element is in first column. So we have to ignore third row and first column. So we will get our minor. Now your second minor is in second column. So ignore third row and second column and you will get 1 2 as your first column and 2 5 is your second column of the minor. And the last element is in last column. So ignore last row and last column and you will get 1 minus 1 and 2 3 as your last minor. Now let's simplify. First of all, let's write down the sign of the cofactors. Then we will simplify our minors. In first minor, you will get 1 3s are 3 minus 0 5s are 0, or we can say we will get 3. Then 1 2s are 2 minus 2 5s are minus 10. So here we'll get 12. Third minor, 0 2s are 0 minus 2 3s are minus 6. So this will become plus 6. Now let's move to the second row. 1 minus 1s are minus 1 minus 0 2s are 0. So here we'll get minus 1, or it will become plus 1. Then 1 1s are 1 minus 2 2s are minus 4. So 1 plus 4 will become your 5. Then 0 1s are 0 minus 2 minus 1s are 2. So this will become minus 2, or we can say plus 2. And in first element of last row will be 5 minus 1s are minus 5 minus 3 2s are 6. So this will become minus 11. Then 5 1s are 5 minus 2 2s are 4. So 5 minus 4 will be 1. Then 3 1s are 3 minus 2 minus 1s are minus 2. So 3 plus 2 will be 5. And don't forget to take transpose. So your adjoint of A will be transpose of this matrix. That means your first row will become your first column. Your second row will become second column. And last row will become your last column. So tada! We get our adjoint of A. In this question, you have to verify that A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into Y. To verify this, we need two quantities. First one, adjoint of A, which is actually adjoint of 2 cross 2 matrix. So It can be easily done by interchanging principal diagonal elements. That means this 2 will move to A22 and this minus 6 will move to A11, and we have to change the sign of rest of the elements. So here we'll get minus 3 and here we'll get 4. So we get adjoint of A. Now second required quantity is determinant of A. We just have to cross multiply. Minus 6 2s are minus 12 minus 4 3s are minus 12 again. So we will get determinant of A equal to 0. Now let's find out all the terms one by one. The first term is product of A into adjoint of A. So let's get your matrix A, which we have to multiply with your adjoint of A. Now we know that both matrices are order of 2 cross 2. That means your resultant matrix will also have order of 2 cross 2. So let's get your first element, which is in first row and first column. So we have to multiply corresponding terms of first row and first column. So we'll get 0. Then the second element is in second column. So multiply corresponding terms of first row and second column. You will get 0. Now let's try to get element of second row. The first element is in first column. So multiply second row and first column. So we'll get 0. And the last element is in last column. Multiply second row and second column. So we will get 0 again. So we can say A into adjoint of A is 0 matrix. Let's call it equation number 1. Now let's try to get your second quantity, which is adjoint of A into A. So your first matrix will be adjoint of A and your second matrix will be matrix A. Again, both matrices are order of 2 cross 2. So your resultant matrix will also have order of 2 cross 2. Now let's get your first element, which is in first row and first column. So we have to multiply first row of first matrix and first column of second matrix. So multiply corresponding term, you will get 0. Then your second element is in second column. So multiply first row and second column and you will get 0. Now let's get elements of second row. The first element is in first column. So multiply second row and first column, you will get 0. And the last element is in last column. So multiply second row and second column, you will get the last element will also 0. So we will get adjoint of A into A is equal to 0 matrix. Now let's get your third and last element, which is determinant of A into identity matrix. And we already find out your determinant of A, which is 0, and your identity matrix is order of 2 cross 2. So you'll get 1 0 0 1. So if we multiply 0, we will get 0 matrix. So from equation number 1, equation number 2 and equation number 3, we can say we get A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Hence proved. Ta-da! In this question, we have to verify that A into adjoint of A equal to adjoint of A into A is equal to determinant of A into I. So to verify this, we need two things. The first thing is determinant of A. So let's expand our determinant with respect to first row. So first of all, we have to place the corresponding sign of cofactor of first elements, which is plus minus plus. Now let's place their elements. And now we just have to find minor of respective elements. So to get first minor, you have to ignore first row and your first column and then cross multiply. 3 zeros are 0 minus 0 minus 2 are 0. Then the minor of second element will be 3 3s are 9 minus 1 minus 2 are minus 2. So this will become plus 2. And the minor of last element 0 3s are 0 minus 1 zeros are 0 again. So we will get determinant of A is equal to your first and last term will be 0, and from the middle term we will get 11. Now the second required quantity is adjoint of A, which is transpose of matrix obtained by cofactors. And to obtain cofactor, first of all, use the symbolic determinant format for the corresponding side of the element. Now we just have to find out minors of them. The first element is in first row and first column. So we have to ignore first row and first column. So we have to multiply 3 zeros are 0 minus 0 minus 2 are 0 again. So your first minor will be smiling 0. Now the second element is in second column. So ignore first row and second column and cross multiply. 3 3s are 9 minus 1 minus 2 are minus 2. So 9 plus 2 will be 11. And the last element is in last column. So ignore first row and third column and cross multiply. 0 3s are 0 minus 1 zeros are 0 again. So we get smiling 0 again. Now let's try to get element of second row. The first element is in first column. So ignore second row and first column and then cross multiply. 3 minus 1s are minus 3 minus 0 2s are 0. So we will get minus 3, or it will become plus 3. The minor of second element of second row is obtained by ignoring second row and second column. So 3 1s are 3 minus 1 2s are 2. So 3 minus 2 will become 1. And minor of last element in second row is obtained by ignoring second row and third column and then cross multiply. 0 1s are 0 minus 1 minus 1s are minus 1. So this will become plus 1. So your last minor will be 1 and cofactor will be minus 1. Now let's try to get minors of third row. The minor of first element is obtained by ignoring third row and first column. So minus 2 into minus 1 will be 2 minus 0 2s are 0. So here we'll get 2. Then minor of second element is obtained by ignoring third row and second column and then cross multiply. Minus 2 1s are minus 2 minus 3 2s are 6. So minus 2 and minus 6 give us minus 8, but your cofactor will be plus 8. And your last minor is obtained by ignoring third row and third column and then cross multiply. 0 1s are 0 minus 3 minus 1s are minus 3. So here we'll get 3 as your cofactor. Now don't forget to transpose the matrix. So your first row will become your first column, your second row will become your second column, and last row will become your last column. So we get our adjoint of A. So we can find out all the terms one by one. So let's begin from the first term, which is A into adjoint of A. So your first matrix will be matrix A. Multiply with your adjoint of A. Now we know that both matrices are order of 3 cross 3. So the resultant matrix will also have order of 3 cross 3. So let's get your first element, which is in first row and first column. So we have to multiply first row of first matrix and first column of second matrix. So multiply corresponding term or we will get 11. Now second element is obtained by multiplying first row and second column. So here we'll get 0. Then the third element of first row is obtained by multiplying corresponding term of first row and third column. So here we'll get 0. Now let's obtain elements of second row. The first element is obtained by multiplying corresponding term of second row and first column. So here we'll get 0. Then the second element will be obtained by multiplying second row and second column. So we'll get 11. And the last element of second row is obtained by corresponding term of second row and third column. So it will be 0. Now let's try to get element of third row. To obtain first element, you have to multiply corresponding term of third row and first column. So it will be 0. Now the second element is obtained by multiplying third row and second column. So it will be 0. And last element is obtained by 11. So we get our first term. Now let's try to obtain your second term, which is adjoint of A into matrix A. So this time your first matrix will be adjoint of A and your second matrix will be matrix A. Both matrices are order of 3 cross 3. So your resultant matrix will also have order of 3 cross 3. Now let's obtain your first element, which is in first row and first column. And for that we have to multiply corresponding term of first row and first column. So you'll get 11. Now obtain second element by multiplying corresponding term of first row and second column. So here we'll get 0. And the last element of first row obtained by multiplying first row and third column. So it will be 0. Now let's try to get element of second row. The first element is obtained by multiplying second row and first column. So we will get 0. Now let's obtain second element by multiplying second row and second column. So we will get 11. And to obtain last element, multiply corresponding terms of second row and third column. So it will be 0. Now let's try to get element of third row. The first element is obtained by multiplying third row and first column. So we will get 0. Now the next element is obtained by multiplying last row and second column. So it will be 0. And the last element is obtained by multiplying last row and last column. So it will be 11. So we get our second quantity. Now let's get your last quantity, which is determinant of A into identity matrix. So let's get your determinant of A and multiply with identity matrix of order of 3 cross 3. So it will become 11 0 0 0 11 0 and 0 0 11. So as you can see, your A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Hence proved. Ta-da! In this question, we have to find inverse of matrix A, which is lower triangular matrix. For that, we need two things. First one, determinant of A, and second one, adjoint of A. So first of all, let's try to get determinant of A. And we know the method. We can expand with respect to first row. But here, you should notice that your matrix is lower triangular matrix. So its determinant can be easily found by multiplying principal diagonal elements. In this case, we have 1 into 3 into minus 1. So the determinant of A is nothing but minus 3. Therefore, A is non-singular matrix and it is invertible. Now, let's try to get adjoint of A, which is nothing but matrix of cofactors of respective elements and its transpose. To get cofactor, let's use symbolic determinant format. Now let's get your first element, which is in first row and first column. So we have to ignore first row of matrix A and its first column. And now cross multiply. Minus 1 3s are minus 3, minus 2 zeros are 0. So minus 3 minus 0 will become minus 3. Now let's try to get second element of the first row. So we have to ignore first row and second column. So minus 1 multiply with 3 will give us minus 3, minus 5 zeros are 0. So minus 3 minus 0 will again minus 3. And the last element is first row is in third column. So ignore its row and column. 2 3s are 6 minus 5 3s are 15. So 6 minus 15 will become minus 9. So we successfully get the elements of first row. Now let's try to get element of second row. Its first element is in first column. So ignore second row and first column and then cross multiply. Minus 1 into 0 will become 0, minus 2 zeros are 0 again. So 0 minus 0 will give us 0. Then the second element is in second column. So minus 1 multiply with 1 will give us minus 1, minus 5 zeros are 0. So here we'll get minus 1. And the last element is in third column. So 2 ones are 2, minus 5 zeros are 0. So 2 minus 0 will be 2. Now let's get element of last row. The first element is in first column. So 0 zeros are 0, minus 3 zeros are 0. So 0 minus 0 will be 0. The second element is in second column. So 0 ones are 0, minus 3 zeros are 0 again. So 0 minus 0 will be 0. And the last element is in last column. So 3 ones are 3, minus 3 zeros are 0. So 3 minus 0 will give us 3. Now, your adjoint of A is nothing but transpose of this matrix. So let's convert its first row into its first column. Then second row will become its second column. And last row will become its last column. So we get our adjoint of A and we are ready to get your inverse of matrix, which is nothing but 1 upon determinant of A into adjoint of A. So let's get 1 upon your determinant of A into the adjoint of A. So we get our inverse of matrix A. Before we go for the next sum, you have to consider that matrix A is a lower triangular matrix. That's why the inverse of matrix is also lower triangular matrix. Use this information smartly to save your time. Ta-da! In this question, we have to find inverse of matrix A, which is upper triangular matrix. And we know that to find out inverse, we need determinant of A and adjoint of A. So first of all, let's find out determinant of A, which is determinant of upper triangular matrix, which can be obtained by simply multiplying principal diagonal elements. That means you have to multiply 1, 2 into 5. Or we can say your determinant of A is simply 10, which is not equal to 0. Therefore, A is non-singular matrix and therefore it is invertible. So let's find out our second required quantity, which is adjoint of A of order of 3 cross 3, which is nothing but transpose of matrix obtained by cofactors. And to obtain cofactor, we are going to need symbolic determinant format, using which we have to place sign of respective elements. Now let's get minor of first element, which is in first row and first column. So we have to ignore first row and first column and then cross multiply. 5 2s are 10 minus 0 4s are 0. So 10 minus 0 will give us 10. Then your next element is in second column. So ignore first row and second column. So you'll get 5 zeros are 0 minus 0 4s are 0. So 0 minus 0 will give us 0. And the last element is in last column. So 0 multiply with 0 minus 0 multiply with 2 will give us another 0. So here we'll get 0 minus 0, or we can say 0. So we get element of first row. Now let's try to get elements of second row. The first element is in first column. So ignore second row and first column and then cross multiply. 5 2s are 10 minus 0 3s are 0. So 10 minus 0 will be 10. Then the next element is in second column. 5 1s are 5 minus 0 3s are 0. So we will get 5 minus 0, or we can say 5. And the last element of second row is in third column. So 0 multiply with 1 will give us 0 minus 0 multiply with 2 will give us another 0. So here we'll get smiling 0. And we get the elements of second row. Now let's move to your last row. The first element is in first column. So ignore third row and first column. So 4 multiply with 2 will give us 8 minus 2 multiply with 3 will give us 6. So 8 minus 6 will give us 2. Then second element of the last row, 4 1s are 4 minus 0 3s are 0. So 4 minus 0 will give us 4, or we can say minus 4. And the last element is in last column. So 2 1s are 2 minus 0 2s are 0. So 2 minus 0 will give us 2. And finally, to obtain your adjoint of A, we just have to take transpose of matrix. So your first row will become your first column, then second row will become your second column, and third row will become your third column. So we get our adjoint of A, and we are ready to find out inverse of A, which is nothing but 1 upon determinant of A into adjoint of A. So let's get your determinant of A and adjoint of A. So we get our inverse of matrix A. Here you should notice that your matrix A is upper triangular matrix and your adjoint of A as well as inverse of A is also upper triangular matrix. Use this information smartly to save your time. Ta-da! In this question, we have to find inverse of matrix A if it is exist. And for that, we need two things: determinant of A and adjoint of A. So first of all, let's try to get determinant of A. So let's expand with respect to first row. So we have to write down the elements of first row with the sign of cofactor and then get the minors of it. So cofactor of first element will be obtained by ignoring its first row and its first column. So let's cross multiply. 1 minus 1 is minus 1 minus 2 zeros are 0. Then the minor of next element can be obtained by ignoring first row and first column. This time we have to cross multiply. 1 with 4 will give us 4 minus 7 with 0 will give us 0. And finally minor of last element. 2 4s are 8 minus 7 minus 1s are 7. So here we'll get 2 into minus 1, or we can see minus 2. Minus 1 into 4 will give us minus 4, and 3 into 1 will be 3. So determinant of A will be minus 3, which is not equal to 0, and therefore matrix A is non-singular and invertible matrix. So now let's try to get adjoint of A, and for that we are going to need symbolic determinant format for 3 cross 3, according to which we are going to place sign. Now we just need to get the minor of respective elements. Now let's get your first element, which is in first row and first column, and for which we have to ignore its first row and first column. So let's cross multiply. 1 multiply with minus 1 will give us minus 1 minus 2 zeros are 0. So minus 1 minus 0 will give us minus 1. Then next element is in second column. So ignore first row and second column and cross multiply. 1 4s are 4 minus 7 zeros are 0. So 4 minus 0 will be 4. Then third element is in third column. 4 2s are 8 minus 7 minus 1s are 7. So 8 minus 7 will be 1. So we get the element of first row. Now let's try to get element of second row. The first element is in first column. So let's ignore second row and first column and then cross multiply. 1 1s are 1 minus 2 3s are 6. So 1 minus 6 will give us minus 5. Then second element is in second column. So 1 2s are 2 minus 7 3s are minus 21, which will give us 23. Now the last element is in last column. So 2 2s are 4 minus 7 1s are minus 7. So 4 plus 7 will be 11. So we get the element of second row. Now let's try to get element of third row. The first element is in first column. So ignore last row and first column and cross multiply. 1 zeros are 0 minus 1 3s are minus 3. So 0 minus 3 will be 3. Now the second element is in second column. So 0 2s are 0 minus 4 3s are 12. So here we'll get minus 12. So it will become plus 12. And the last element is obtained by last column. So minus 1 2s are minus 2 minus 4 1s are 4. So minus 2 minus 4 will be minus 6. Now finally, to get adjoint of A, we just have to take transpose, in which your row will be converted into columns. So your first row will become your first column, then second row will become your second column, and the last row will become your last column. So we get adjoint of A and we are ready to find out A inverse, which is nothing but 1 upon determinant of A into adjoint of A. So let's get 1 upon your determinant of A and your adjoint of A. So we get our inverse of matrix. Ta-da! In this question, we have to find inverse of matrix if it is exist, and for that we need determinant of A and adjoint of A. So first of all, let's find out determinant of A. So let's expand with respect to first row. So we have to write down its elements with their proper sign for cofactors. And now let's get their minors. The minor of first element is obtained by ignoring first row and first column and then cross multiply. 4 2s are 8 minus 2 into minus 3 will be 6. And the minor of second element will be obtained by ignoring first row, second column. 4 zeros are 0 minus 3 minus 3s are minus 9. And now minor of last element, minus 2 zeros are 0 minus 3 2s are 6. So here we'll get 1 into 2, 2, minus minus become plus, again minus minus become plus, and we'll get 9, and 2 minus 6 are minus 12. So determinant of A will be minus 1, which is not equal to 0. Therefore, A is non-singular and invertible matrix. So let's find out adjoint of A of order of 3 cross 3. And for that, we are going to need symbolic determinant format for 3 cross 3 for sign which we use in cofactor. Now we just have to find out minor. Let's get minor of first element, which is in first row and first column. So we have to ignore first row and first column and then cross multiply. 4 2s are 8 minus 2 minus 3s are 6. So 8 minus 6 will be 2. Then the second element is in second column. So 4 will multiply with 0 minus 3 minus 3s are minus 9. So 9 minus minus 9 will be 9. And the last element of first row is in third column. So minus 2 zeros are 0 minus 3 2s are 6. So 0 minus 6 will be minus 6. So we get element of first row. Now let's try to get element of second row. The first element is in first column. So ignore second row and first column and then cross multiply. 4 minus 1s are minus 4 minus 2 2s are minus 4 again. So here we'll get 0. Then second element is in second column. So 4 1s are 4 minus 3 2s are 6. So 4 minus 6 will give us minus 2. And the last element is obtained by minus 2 1s are minus 2 minus 3 minus 1s are minus 3. So here we'll get 1. So we get element of second row. Now let's try to get element of third row. The first element is in first column. So cross multiply. Minus 3 minus 1s are 3 minus 2 2s are 4. So 3 minus 4 will give us minus 1. Then second element is in second column. Minus 3 1s are minus 3 minus 0 2s are 0. So minus 3 0 will give us minus 3. So this will become plus 3. And the last element is in last column. So 2 1s are 2 minus 0 minus 1s are 0. So it will give us 2. So finally, to get adjoint of A, we just have to take transpose of this matrix. So your first row will become your first column, then second row will become your second column, and your last row will become your last column. So we get our adjoint of A, and we are ready to find out inverse of A, which is 1 upon determinant of A into adjoint of A. So let's get 1 upon your determinant of A and get your adjoint of A. So if we multiply minus 1 within the elements, their signs will be changed. So we'll get minus 2, 0, 1, 9, 2, minus 3, and 6, 1, and minus 2, which will be your A inverse. Ta-da! In this question, we have to find inverse of matrix A if it is exist, and for that we are going to need determinant of A and adjoint of A. So first of all, let's find out determinant of A. Let's expand our determinant with respect to first row. So the only non-zero term is first one. Rest of the terms are 0, so we don't have to worry about them. Just find out minor of 1 by ignoring its row and its column. So minus cos alpha will give us minus cos square alpha minus sin alpha into sin alpha will give us sin square alpha. So determinant of A will be minus 1, which is not equal to 0. Therefore, A is non-singular and invertible matrix. So let's find out adjoint of A of order 3 cross 3, and let's use symbolic determinant to get sign of cofactor. Now we just need to get minor of all the elements. The first element is in first row and first column. So let's ignore first row and first column and then cross multiply. Minus cos alpha will give us minus cos square alpha minus sin alpha into sin alpha will give us sin square alpha. So this will become minus 1. Then the next element is in second column. So ignore first row and second column and then cross multiply. Minus cos alpha zeros are 0 minus 0 into sin alpha will be 0. So 0 minus 0 will be 0. Similarly, the last element will also 0. So here we get the element of first row. Now let's try to get element of second row. The first element is in first column. So ignore them and cross multiply. Minus cos alpha into 0 will give us 0 minus sin alpha into 0 again 0. So here we'll get smiling 0. Now the next element is in second column. So ignore second row, second column and cross multiply. Minus cos alpha into 1 will be minus cos alpha minus 0 into 0 will be 0. So here we'll get minus cos alpha. And the last element of second row is in third column. So sin alpha into 1 will give us sin alpha and 0 into 0 will be 0. So here we'll get sin alpha. So we get the elements of second row. Now let's try to get element of third row. The first element is in first column. So ignore third row and first column and you will get sin alpha into 0 will be 0 minus cos alpha into 0 again 0. So we again get smiling 0. Now the second element is in second column. So sin alpha into 1 will be sin alpha minus 0 into 0 will be 0. So here we'll get sin alpha. And the last element is in last column. So in our last row, last column will give us cos alpha minus 0, or we can say cos alpha. So we can say to get adjoint of A, now we just have to take transpose of it. So its first row will become its first column, then second row will become its second column, and last row will become its last column. So we get adjoint of A, and we are ready to find out inverse of matrix, which is nothing but 1 upon determinant of A into adjoint of A. So let's get 1 upon determinant of A into your adjoint of A. In further simplification, we have to multiply minus 1 within the matrix. So the sign of all elements will change. So we get A inverse. But if you see carefully, this is same as our given matrix. This kind of a matrix where A inverse is equal to A is known as involutory matrix. Ta-da! In this question, we have matrix A and B, and we have to verify that AB inverse is equal to B inverse into A inverse. So let's try to get them one by one. First of all, let's try to get left hand side, and for that we are going to need A into B. So let's multiply matrix A with matrix B. Both matrices are order of 2 cross 2. That means your resultant matrix will also have order of 2 cross 2. So let's try to get first element, which is in first row and first column. So we have to multiply first row of first matrix and first column of second matrix. So here 3 6 are 18 plus 7 7s are 49, or we can say we will get 67. Then the next element is in second column, so it will be 87. So we get the element of first row. Now let's try to get element of second row. The first element is in first column, so multiply respective terms. 47, and the last element is in last column, so it will be 61. So here we get A into B, or let's say matrix C, and we need the inverse of matrix C, and for that we are going to need determinant of C, which can be obtained by cross multiplying 61 with 67, or we can say 4087 minus 47 into 87 will give us 4089. So it will be minus 2, which is not equal to 0. So we can say your C inverse does exist. And the second quantity which we need is adjoint of C. Your C is order of 2 cross 2. So its adjoint can be easily found by interchanging principal diagonal element. So this 67 will move to the A22 and 61 will move to A11, and for the rest of the elements we have to change their sign. So here we'll get minus 87 and minus 47. So we get our adjoint of A, and we are ready to find out inverse of C, which is 1 upon determinant of C into adjoint of C. So let's get 1 upon your determinant of C and multiply with adjoint of C. So we get our left hand side. Now let's try to get your right hand side. The first term we need is A inverse, and for that let's write down matrix A. Let's get determinant of A by cross multiplying. This 5 will multiply with 3 will give us 15 minus 2 sevens are 14, or we will get 1, which is not equal to 0. Therefore, A inverse does exist. Now the second thing we need is adjoint of A. Your matrix A is order of 2 cross 2. So, to get adjoint, we simply have to change the position of principal diagonal elements. That means this 3 will move to A22 and this 5 will move to A11, and rest of the terms have to change the sign. So here we'll get minus 7 and minus 2. So we get our adjoint of A and we are ready to get inverse of A, which is nothing but 1 upon determinant of A into adjoint of A. Your determinant of A is 1 and your adjoint of A is this matrix. So we get our A inverse. Now the last quantity which we have to find is B inverse. So let's get matrix B. Now the first thing we need is determinant of B. So let's cross multiply. 9 6 are 54 minus 7 8 are 56. So we'll get minus 2, which is not equal to 0. Therefore, B inverse does exist. Now let's try to get adjoint of B, where B is 2 cross 2 matrix. So to get adjoint, we just have to interchange principal diagonal elements. That means your 6 will move to A22 and this 9 will move to A11, and we have to change the sign of rest of the elements. So here we'll get minus 8 and minus 7. So we can say we get our B inverse, which is nothing but 1 upon determinant of B into adjoint of B. So let's get your determinant of B and your adjoint of B. So we get our B inverse. Now your right hand side is B inverse into A inverse. So let's get your B inverse and multiply with your A inverse. Now this 1 by 1 is 1. We don't have to worry about it. So let's matrix multiply. Both matrices are order of 2 cross 2. So we can say your resultant matrix will also have order of 2 cross 2. So let's try to get first element, which is in first row and first column. So multiply first row of first matrix and first column of second matrix, or we will get 61. Then the next element is in second column. Multiply corresponding term and we'll get minus 87. Now the first element of second row is in first column. So multiply corresponding terms and we'll get minus 47. And the last term is in last row and last column. So it will be 67. So here we get our right hand side, which is same as your left hand side. So we can say your left hand side, which is AB inverse, is equal to your right hand side, which is B inverse A inverse. Hence proved. Ta-da! In this question, we have one matrix A. And first of all, we have to show that A cube minus 5A plus 7I is equal to 0 matrix. And then, using this equation, we have to find the value of A inverse. So, let's try to prove our matrix equation. And for that, we are going to need A square, which is nothing but multiplication of A with itself. So, the first row of matrix A is 3, 1 and second row is minus 1, 2. Should be multiplied with itself. Here, both matrices are of order of 2 cross 2. So, we can say the resultant matrix will also have the order of 2 cross 2. So let's obtain your first element, which is in first row and first column. So let's multiply first row of first matrix and first column of second matrix, or we can say we will get 8. Then the next element is in second column, which will give us 5. So we get the elements of first row. Now let's try to get element of second row. The first element is in first column, so multiply respective terms. So here we'll get minus 5. And the last element can be obtained by multiplying second row and second column. So here we'll get 3. So we get our matrix A. Now let's obtain your second quantity, which is minus 5A. So we have to multiply minus 5 with each element of the matrix A. And your last quantity is 7I. We have to multiply 7 with identity matrix of order 2 cross 2. So we get all the elements to obtain our left hand side, which is A square minus 5A plus 7I. So your first quantity is your A square plus the second quantity is minus 5A, and finally the last quantity is 7I. Now let's add respective elements. This will be 0 matrix, which is your required right hand side. So we can say your left hand side, which is A square minus 5A plus 7I, is equal to your right hand side. Hence proved. Now let's move to the second part of the question, in which we have to find A inverse using your equation number 1. And for that, let's multiply your entire equation with A inverse. So A inverse into A square will give us A, then minus A inverse into A will give us identity matrix, plus A inverse into 7I will give us 7A inverse, and A inverse into 0 matrix will be 0 matrix. So here we have to make 7A inverse objective. So we will get 5I minus A. So we can say if we multiply 5 with identity matrix, we will get 5005 minus your matrix A is already given as 3 1 minus 1 2. Now for further simplification, let's take a difference between corresponding terms. 5 minus 3 will give us 2, 0 minus 1 will be minus 1, 0 minus minus 1 will be 1, and 5 minus 2 will be 3. So we get our 7A inverse, but we need A inverse. So we have to move this 7 on the right side, so it will go in the denominator. So tada! We get our A inverse. In this question, we have one matrix A, and we have to find the value of A and B such that A square plus AA plus BI is equal to 0 matrix. So to use this matrix equation, we have to find all the quantities. First of all, we have to find your first quantity, which is A square, or we can say A into A. So let's write down your matrix A. Its first row is 3 2 and second row is 1 1, and multiply with itself. We know that our matrix is order of 2 cross 2. So your resultant matrix will also have order of 2 cross 2. That means we will have 2 rows and 2 columns. So let's obtain your first element, which is in first row and first column. So we have to multiply elements of first row of first matrix and first column of second matrix. So here we'll get 3 3s are 9 plus 2 1s are 2. Or we can say 9 plus 2 will be 11. Then the next element is in second column. So multiply respective terms. 3 2s are 6 plus 2 1s are 2. Or we can say 6 plus 2 will give us 8. So we get the element of first row. Now let's try to get element of second row. The first element is in first column. So multiply elements of second row and first column. So 1 3s are 3 plus 1 1s are 1. Or we can say 3 plus 1 will give us 4. And the last element is in second column. So 1 2s are 2 plus 1 1s are 1. Or we can say 2 plus 1 will give us. So we get our first term, which is a square. Now let's try to get your second element, which is a into matrix A. So we have to multiply A with each element of matrix A. So we will get 3A, 2A, A and A. And similarly, the last element is BI. We have to multiply B with identity matrix of order 2 cross 2. So it will give us B0 and 0B. And we are ready to use our matrix equation. Your first matrix is matrix A square plus the second matrix is A matrix A, and your third matrix is BI, and it is equal to your 0 matrix. Now let's simplify. We have to add first element of all matrix and compare with the right hand side. So we'll get 11 plus 3A plus B is equal to 0. Let's call it equation number 1. Now similarly, from second element we will get 8 plus 2A plus 0 is equal to 0, which will give us equation number 2 as well as the value of A, which is minus 4. Now let's substitute the value of A in your first equation. So we will get 11 plus 3 times A, or we can say minus 4 plus B equal to 0, which will give us B is equal to 1. So we get the value of A and B, but before we conclude the answer, we have to compare another elements also. So from third element, we will get 4 plus A is equal to 0, which will give us A is equal to minus 4, which will give us same result. Now compare the last element and you will get 3 plus A plus B is equal to 0, which satisfied the value of A and B. So we can say we have unique value of A and B which satisfied our matrix equation. Ta-da! Here we have a very long question. We have matrix A of order 3 cross 3. And initially we have to show that A cube minus 6A square plus 5A plus 11I is equal to 0 matrix. And then we have to find the value of A inverse using this equation. Now I is your identity matrix and matrix A is given. So let's try to get A square, which is A into A. So let's write down matrix A and multiply with itself. We know that both matrices have order 3 cross 3. So your resultant matrix will also have order of 3 cross 3. That means we will have 3 rows and 3 columns. So let's obtain your first element, which is in first row and first column. So multiply your first row of first matrix with first column of second matrix. So 1 ones are 1 plus 1 ones are 1 again plus 1 twos are 2, or we can say 1 plus 1 plus 2 will give us 4. Then the next element is in second column. 1 ones are 1 plus 1 twos are 2 plus 1 minus 1s are minus 1. So minus 1 plus 1 will cancel out and you will get 2. Then the last element of first row is in third column. So multiply respective terms. So here and we will get 1. So we successfully get the element of first row. Now let's try to get element of second row. The first element is in first column. So multiply respective terms. 1 ones are 1 plus 2 ones are 2 plus minus 3 into 2 will give us minus 6. So 1 plus 2 minus 6 will give us minus 3. Then the next element, so 1 plus 4 plus 3 will be 8. Then your last element of second row is in third column, will give us minus 14. So we get the element of second row. Now let's try to get element of third row. The first element is in first column, so we will get 7. Then the second element is in second column and we will get minus 3. And the last element is in last column, which will give us 14. So we get our matrix A square. Now for the first element, we need to get A cube, which is A square into A. So let's try to get your matrix A square and multiply with your matrix A. Both matrices have order of 3 cross 3. That means your resultant matrix will also have order of 3 cross 3. So we will get 3 rows and 3 columns. So let's get your first element, which is in first row and first column. So we have to multiply first row of first matrix and first column of second matrix, or we can say we will get 8. Then your next element is in second column. So 4 plus 4 minus 1 will give us 7. Now the last element of first row is in third column. So 4 minus 6 plus 3 will give us 1. So we get element of first row. Now let's try to get element of second row. The first element is in first column, minus 23. The next element is in second column, will become 27. And the last element of second column is minus 69. And the element of third row, first column, will be 32. Then minus 13. And last element will be 58. So here we get our A cube. So we get A cube and A square. Now let's try to prove our matrix equation. In left hand side we have A cube minus 6A square plus 5A plus 11I. So first of all, let's try to get your matrix A cube plus, to obtain minus 6A square, we have to multiply minus 6 with A square. Then plus 5A can be obtained by multiply your matrix A with 5 plus the last element, which is 11i, can be obtained by multiplying 11 with the identity matrix. Now for simplification, we have to add respective elements. So 8 minus 24 plus 5 and plus 11 will give us 0. Similarly, 7 minus 12 plus 5 plus 0 will also give us 0. Then the third element will be 0. Similarly, the rest of the terms will be 0. So we will get 0 matrix on the right hand side. So we can say your left hand side is equal to your right hand side. Hence proved. So we complete our first part of the question. Now let's try to obtain a square using this equation, and for that we have to multiply whole equation with a inverse. So a inverse into a cube will give us a square, then a inverse into 6a square will give us 6a, then a inverse multiplied with third term will give us 5i, and a inverse into 11i will give us 11a inverse. And on right hand side we have 0 matrix, so we don't have to worry about it. So from this equation, if we make 11a inverse subjective, we will get minus a square plus 6a minus 5i. So to obtain a inverse, we are going to need minus a square, and for that we have to multiply your a inverse with minus 1 plus your second element is 6a, or we can say we have to multiply 6 with matrix A, and finally your last term is minus 5i3, or we can say we have to multiply minus 5 with identity matrix. So let's add respective elements. Minus 4 plus 6 minus 5 will give us minus 3, then minus 2 plus 6 plus 4 will give us 4, then minus 5, 6, 0 will be 5, then 3, 6 and 0 will give us 9, minus 8, 12, minus 5 will be minus 1, 14 minus 18, 0 will be minus 4, minus 7, 12, 0 will be 5, 3 minus 6, 0 will be minus 3, minus 14, 18 and minus 5 will be minus 1. So here we get 11a inverse. So we can say your a inverse is nothing but 1 upon 11 into this matrix. So we complete our second part also. Ta-da! Here we have very long question. We have matrix A, and initially we have to verify a cube minus 6a square plus 9a minus 4i equal to 0 matrix, and hence we have to find a inverse. So first of all, let's try to solve your first part. The last term of the matrix equation is 4i, which is multiplication of 4 with identity matrix. A is given, so let's try to get a square, which is a into a. Let's write down your matrix A and multiply with itself. Both matrices have order of 3 cross 3. So the resultant matrix will also have order of 3 cross 3. That means we will have 3 rows and 3 columns. So let's obtain your first element, which is in first row and first column. So multiply first row of first matrix and first column of second matrix. So 2 2s are 4 plus minus 1 are 1 plus 1 1s are 1, which will give us 6. Then second element is in second column. So 2 minus 1s are minus 2 plus minus 1 2s are minus 2 plus 1 minus 1s are minus 1, which will give us minus 5. Then the last element of first row is in third column, which will give us 5. Now let's try to get elements of the second row. The first element is in first column, which will give us minus 5. The next element is in second column, so we'll get 6. Then the last element of second row will be minus 5. Now let's try to get element of last row, which is your third row. Its first element is in first column. Now you should notice that matrix A is symmetric matrix. That means A square will also symmetric matrix. So element A31 should be equal to element A13. So if we multiply corresponding terms, we will get 5 as we predicted. Similarly, let's try to get next element should be minus 5, and the last element can be obtained by 1 multiply with 1 will give us 1 plus minus 1 multiply with minus 1 will give us 1 plus 2 multiply with 2 will give us 4, or we can say we will get 6. So we get our A square. Now the next required quantity is A cube, which is A square into A. So you have to multiply your A square with matrix A. So by matrix multiplication, we will get A cube. So we are ready to verify our matrix equation. Your left hand side is A cube minus 6A square plus 9A minus 4I. So your first matrix is A cube plus the next matrix is minus 6A square. That means we have to multiply minus 6 with your A square plus, let's obtain your 9A by multiplying 9 with matrix A, and your last element is minus 4I. So we can say minus, we have to multiply 4 with identity matrix. Now let's add respective elements. So we will get 22 minus 36 plus 18 plus 4 will be 0. Then minus 21 plus 30 minus 9 plus 0 will also 0. Similarly, your next element will be 0. And if we add respective elements of second row, we will get 0, 0 and 0. Similarly, from respective element of third row, we will get 0, 0 and 0, which is your 0 matrix and also required right hand side. So we verify your first part of the question, in which you obtain that your A cube minus 6A square plus 9A minus 4I is equal to 0 matrix. Now let's move to the second part of the question, in which we have to find A inverse using this equation, and for that we have to multiply A inverse to the whole equation. So A inverse into A cube will give us A square Then from second term we'll get minus 6a. Then your third term will give us 9i, and in last term we will get minus 4a inverse is equal to 0 matrix. So if we make 4a inverse subjective, we will get a square minus 6a plus 9i. So we have to substitute respective elements. First of all, let's get your matrix a square plus your second element is 6a. So we have to multiply minus 6 with each element of matrix A plus your last element is 9i, which can be obtained by multiplying 9 with identity matrix. Now let's add respective elements. So we get our 4a inverse, or we can say your A inverse is nothing but 1 by 4 of this matrix. So ta-da! We complete our question. In this MCQ, we have one matrix A which is non-singular square matrix of order 3 cross 3. So your n is 3. Then we have to find determinant of adjoint of A, and using third property we can say it is equal to determinant of A raised to n minus 1. In this case your n is 3. So we will get determinant of A raised to 3 minus 1, which is nothing but 2. So option B is your final answer. Ta-da! In this question, we have a matrix A which is invertible matrix of order 2, and we have to find determinant of A inverse. And according to property of determinant, it is simply 1 upon determinant of A, which is given in option B. Ta-da!